Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, I'm going to be talking about Newman projections and two of the most important nomenclatures known as eclipsed and staggered. So Newman projections are a way to translate complex 3D information about a molecule into 2D representations that are a little easier to understand. These are helpful for understanding torsional effects and conformational effects as well. So we'll start out with a relatively straightforward molecule, ethane. I'm going to convert this formula into a 3D structure. So this is one conformer of ethane. Another conformer of ethane looks like this. So what's the difference between them? First, the left side of the molecule is exactly the same, but the one on the right is a little different. What's happened is this molecule has been rotated, this side of the molecule has been rotated by about 180 degrees. Remember, you can rotate around single bonds. So sometimes it's necessary to translate this 3D information into 2D information. The Newman projection works by looking down one bond and shows the relative orientation of all dependent atoms and groups. First thing you need to do is to draw a circle. In the middle of that circle, we'll put a dot, okay? And that dot is meant to represent the eclipsing of those two carbons. So we're looking at it from the side, but if we turned it this way, you would see that there'd be an eclipsing of my two hands. Those are the two carbons. And if we follow these structures, I'm going to just indicate these different groups with underlining. If we look down that bond, you'll see that this hydrogen, which I'm underlining once in blue, is pointed up. This hydrogen, which I'm underlining twice in blue, is pointed to the right. And then this hydrogen, which I'm underlining 3 times, is pointed to the left. Okay. And then there's a second component to the Newman projection, which is the atoms that are in the back. In other words, onto the second atom, the second carbon atom, or the right carbon atom. So here, looking down this bond again, right, the hydrogen that I'm underlining in red once is pointed down, right? And it's opposite to the hydrogen underlined once in blue. Towards the up and right is the hydrogen underlined here twice in red. And the circled hydrogen here in red is the one that's pointed up and left. And when the hydrogens are arranged in this way, this is considered a staggered conformation. And this is a low energy conformation. So we're looking at ethane, but a different conformation of this ethane. So first thing we're going to do, just like before, is draw this circle. We're going to draw the dot in the middle to represent the carbons that are eclipsed. And you'll notice right away that this hydrogen is pointed up. This hydrogen that I've underlined once is down and left. And this hydrogen that I've underlined twice is down and right. Moving on to the next carbon, you have another hydrogen that's pointed up, which I've circled in red and indicated in red here. And you'll notice that that carbon-hydrogen bond is a little shorter, but that's just for perspective. These are exactly aligned with one another. You should make a model to convince yourself of this if you can't see it from my iPad drawing. Also are eclipsed. You can see this one that I've underlined twice is down and right. And this one that I've underlined once is down and left. Okay, and this is known as an eclipsed conformation because the two structures have bonds that are exactly eclipsed. In relative terms, the staggered is the lower energy structure, so it's 0. And the eclipsed structure is about 3 kcals per mole higher in energy than the staggered. And we can talk about this more in class, but the difference between these translates to about 100 to 1 preference for staggered. There aren't really any exceptions for this. These are just how to draw Newman projections. Okay, so that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.